All right, so here we have the Itty Bitty telescope. We designed this during our free time out of class. This telescope is to detect the sun at frequencies of 12 gigahertz. And we found this assembly of parts based off a website. We found all the parts we needed to build it, and we had to order it from various locations like Amazon, eBay. I think we got some from Walmart, and we used some other tools around the physics department. So here we'll start with the dish. So this is our main dish that we got from DirecTV. It's just a normal TV dish that we had. And we have this LMB arm that helps detect frequencies, or helps detect the rays off the dish. We got two different lengths of coax cables that we had to properly put into place. We got a battery pack for a power source, and the hardest part was the RF choke that we'll talk about later. We have a stand here with some clamps to make sure we can stabilize it in a certain position, as well as our channel master that detects our signals in different frequencies, in voltage or our certain frequency range we're looking to observe. And we're going to go on and talk about our procedure of how we put all these things together. And
so for the procedure, we kind of just did it at the time that each piece came in, because some things took a little longer depending on where we got each piece. So the cables came in pretty fast with the battery pack and the satellite dish. We had to wait for to start anything really about this. So first what we started was taking our 4-foot coax cable and running it through the arm so we could connect it to the LMB. And after running it through, we wanted just to follow the instructions that came with the DirecTV dish of how to assemble with its mount, because you can see we could rotate it depending on where we want it to face. Yeah, you're right. So you could see on the back that we could rotate it on this mount right here, and then we could also change how up it's facing versus down. And we really just followed the instructions for that on the procedure that came with it. So then once we got the satellite pretty much in place and all those pieces connected with the cable coming through, we connected that to our channel master in the LNB port. And then our hardest part was with the 2-foot cable. We had to connect the RF choke and the battery holder in a certain way that we found with our instructions guide that we found when researching the Itty Bitty telescope. So you can see we had to solder the RF choke into place with the black and red wire. The red wire goes at the end of the RF choke, while the black wire had to go before it in the cable. And then we wrapped it up with some electrical tape to keep that safe and secure. And then we plugged that part back into the channel master. And then at the end, we kind of just threw this dish onto a tripod we found with some clamps, because we didn't want to screw it in place straight away, but it's actually been working out pretty well. So that's how we kind of set up our telescope, and now we'll go into what it's supposed to do more and future things we need to do to it.
Yeah, so pretty much the way this is supposed to work is we're supposed to be able to point this dish at some radiating surface. For the best readings, they recommend the sun, because that's how we see the largest change in the received frequency of emission. And so to detect this, we connected all these wires, or the coax cables, to the channel master here. And so with power being given to the channel master, we should be able to turn this guy on. So let's turn on the battery pack, and you can see that there's a noise coming out of the satellite finder, and in an ideal world, how this should work is we should be able to change the gain so this reading goes all the way to 0, and once we point the satellite at the sun, for example, then we would see this red needle go up to a different reading. But in this case, we weren't able to zero out the initial reading, and even when we point it at the sun, or even the ground as they said in the instructions to see a difference, the needle wouldn't move at all. So what we're thinking is this might be a faulty satellite finder, and it's not working because all the cables are connected correctly, along with all the wiring down here is exactly how it's supposed to be, with the RF choke being in series with the positive terminal of the battery clip and the coax cable. So in the future, maybe if they were to rewire this again, changing the direction of the choke, it shouldn't really make a difference because it's said that the orientation of the choke is irrelevant. So we're led to believe that we would need a new satellite finder, and if that doesn't work, then it might have to do with our power supply or our dish entirely if it's not picking up the correct signals that we desire. Also, the future endeavors of our satellite would to be put on a more permanent base. So right now it's super temporary with it just being on a tripod with these clamps. We purchased a wooden base. It's a 2x2 piece of plywood, and we're supposed to put the actual dish mount on a Lazy Susan, but the Lazy Susan that we bought was too small for the base, and so we weren't actually able to use this specific Lazy Susan, and we didn't have time to order a new one. So in the future, we would need to get a larger Lazy Susan in order to put on our base plate. That way we can rotate the entire dish without having to move the tripod. But at the same time, this mount is good enough so that we can play with the orientation of the dish a lot. It's just more convenient for transportation and storage and that kind of stuff. So yeah, that is our itty bitty telescope. We hope that any groups that take this project on in the future can solve our problems, and hopefully this video is of some help. We can also link the instruction manual that we use. That way you have some other reference on how to build the itty bitty telescope. Thank you.